Okay, so solving this with a Windows calculator, subtract that subtract that 0.983 from both sides. So you get cotangent of theta equals negative 0.983. So to get theta by itself, we want to use inverse theta inverse cotangent to both sides, because the inverse of an original function, it's like it cancels out, right? So we need to do the same thing over here. Okay, it undoes the work of the function. If you have an inverse, if you plug in the original function, and let's say y was the variable of that function, then the inverse of the original leaves you with just the whatever was in the parentheses on the inside. It's similar to canceling out. Okay, so inverse cotangent of cotangent cancels out, leaves us just theta. So we need this inverse cotangent of negative 0.983 in our calculator. So 0.983 negative, and then the Windows calculator, if you hit trigonometry, to get inverse, you just hit this second key, and there's inverse cotangent. So and that's negative 0.7939. Now, check it out. My calculator was already in radians. Watch out for that. Make sure if there's no degree symbol, or if it doesn't specify degrees, then you can assume radians. But you'd want to click this and turn it into degrees if you are working in degrees. And then another thing is that the problem usually has a little extra specification in here. They want all angles that are between 0 and 2 pi. That's your indicator that it's radians, because when you're talking about pi, you're talking about that circumference of the unit circle. So this is the answer I got here was a negative answer. We want all the answers within this unit circle. So one thing we can do, let me see what the easiest way is. Is that really what I got? Yeah. What did I type here? Oh, that's because I switched to degrees. Okay, so 0.983 negative. I'm just double checking. Inverse cotangent. Yeah, okay. That's negative, right? This is saying between 0 and 2 pi. So one thing we can say about tangent and cotangent is that they have a period of pi, which means they repeat themselves every pi units on the x-axis. So if we wanted theta of negative 0.7939, we're going to get the same thing. We'll have the same result if we add pi to it. So if we add pi to it, that would also solve the equation. There's an infinite amount of solutions. Where's pi? Right there. So there's one solution. So 2.348. Let's add another pi to see if it fits in these parameters. 5.489. 5.489. And that fits because 2 pi is a decimal. 6.28. So these are our two solutions. But again, I don't have this information. I don't know for sure it's saying this. But remember, with trigonometry, you have an infinite amount of solutions. So there's usually some sort of specification that says, give me all the solutions between 0 and 2 pi. And so that would be this here.